Today we're going to control this simple two-wheeled robot using a clone of an Adafruit motor shield on top of an Arduino. So here is the motor shield. It's pretty straightforward. The motor shield basically pops directly into the pins on the Arduino. You line them up and you push it in. For the robot here, I'm using the Actobotic Sprout, which was probably around $15. I'll put a link to that in the YouTube description. So on this chassis, there's a slot where we can just plug in our Arduino plus the motor shield. Get a little tighter there. There's basically terminals around the perimeter of the board for different motors. For the purposes of this tutorial, I'm using M2 and M3, which are on either side, to correspond to the left and right motors. So basically just pop in the connectors, and then you screw them in. So those were both of the motors. Now I'm connecting. I have a little 4 AA battery caddy over here. So we gotta do ground. Let's do one at a time. So screwing in the ground here. We'll get the positive. And I also have another 4 AA battery caddy in the bottom, connected to some female connectors, and we're going to do positive to 9 volts and ground to ground here. And I actually soldered on these headers, these 3 here and this one here, just to make it easier to work with. Alright, let's just make sure everything's tightened. So that's how you connect everything. There's some good videos online about how to put together this chassis. It's all just pop in with plastic pieces. So let's move on to the code here that we're going to test. Okay, so in my GitHub repository, you can see that there's now a 2-motor test sketch available. We'll take a look at it. So it's basically just going to run through some of the different operations that we can do here with these motors. And at the beginning in the comments, I'm just going through each of the different tests we're going to run through. And then I also have a link to the Adafruit website that has a good tutorial on how to use this. So at the beginning, at the top here, we're going to set up the motors. This is using the AF motor library that I also downloaded from that link. Defined a delay in milliseconds. So for most of the operations we're going to do it for 500 milliseconds or half a second. In setup, we're just setting up serial and printing out a little message to say we're starting. And then there's the main loop. So here we're going to go forward and then backwards. We're going to turn left and then right in place. We're going to arc forward and arc backwards to both the left and the right. So just to go through how we use some interface with the motor a little bit. If you want to have the motor stop moving, you can just run the release command. To turn right in place, you're going to move the left motor backwards and the right motor forward. And basically, at any point, you can set the speed that both of the motors are going to be operating on. Same goes with turn left. You just do the left one forward and the right motor backwards. So to move forward, you just set them both to be forward, and same deal with backwards, both go to backward. So I'll go down to the bottom here. So the set speed library function is what will set the output of the motor essentially. So I'm taking in a percentage that's really just a number, an integer from 1 to 100, and we're mapping it to an integer between 1 and 255, which is what the output of the motor, what the motor shield is expecting as to set for the output. And then I just have a little helper function at the bottom for printing out some information for serial for debugging. So basically each of these battery caddies has an on-off switch. There's one on the bottom. It's a little hard to get to. And then it should start moving. Oops. And sometimes either the gears or the wheels seems to jam up a little bit. So there we went through some code on how to get a Arduino to control a little two-wheeled robot. For the next time, we'll probably maybe hook it up with the ultrasonic sensor from before and have a little more sophisticated control of the motors. So thanks for watching.